So now we are going to see the mechanism of uh, sulfonamides. Just wait a minute. Okay, this is the mechanism of action of sulfonamides. Para-aminobenzoic acid, it will react with pteridine. This is a normal synthesis of folic acid in the bacteria. Okay, so para-aminobenzoic acid, it will react with pteridine in presence of pteridine synthetase enzyme. So this PABA means para-aminobenzoic acid, is going to attach itself on the surface of pteridine synthetase enzyme, and it will produce dihydropteroic acid. So pteridine is converted to dihydropteroic acid. This dihydropteroic acid is a substrate for the enzyme dihydrofolate synthetase to synthesize dihydrofolic acid, which is also called as DHFA. Okay, this DHFA will serve as a substrate for the enzyme dihydrofolate reductase, okay, DHFR, to form tetrahydrofolic acid, THFA. And tetrahydrofolic acid is further going to synthesize thymidine, purines, and methionine. So it is going to synthesize DNA and RNA. So this is the general flow of the mechanism of synthesis of folic acid and DNA in the bacteria. Okay, human beings, we take the folic acid as a dietary supplement, that is, in the diet we take folic acid. We are not in a position to synthesize folic acid. Okay, so this is taking place in the bacteria. Now, where the sulfonamides will act? Sulfonamides, they will replace the para-aminobenzoic acid, that is PABA, because sulfonamides are acting as bioisosteres of PABA. Why? Because the structure of para-aminobenzoic acid and sulfonamide is a bit similar. So the pteridine synthetase, it will mistakenly accept sulfonamide as its natural precursor PABA. ओके, सो टेरिडिन सिंथेटेज गलती से एक्सेप्ट करता है सल्फोनामाइड को, और जो डायहाइड्रोटेरोइक एसिड जो सिंथेसाइज होने वाला है वो होगा नहीं, राइट, बिकॉज इट इज नॉट पाबा, इट इज सल्फोनामाइड विच इज रिएक्टिंग विद टेरिडिन. Now this whole process is then disrupted. जो डायहाइड्रोफोलिक एसिड, टेट्राहाइड्रोफोलिक एसिड सिंथेसाइज नहीं होता है, उनकी जगह पे फॉल्टी या फॉल्स प्रिकर्सर तैयार होगा, एंड यू विल गेट अ फॉल्टी thymidine, faulty purine, faulty methionine, and finally faulty DNA. Okay, so this process is hampered by sulfonamide. And ट्राइमिथोप्रिम और पायरीमिथामाइन जो हमने पहले देखा है, ट्राइमिथोप्रिम, it will and pyrimethamine, they will replace the dihydrofolic acid substrate for the dihydrofolate reductase enzyme, and it will inhibit the trimethoprim and pyrimethamine will inhibit the dihydrofolate reductase, it is a DHFR enzyme. And finally it is also going to help out the sulfonamide, just like sulfonamide. So both actions are synergistic. सल्फोनामाइड पहले की स्टेप को वो इनिबिट करेगा, और ट्राइमिथोप्रिम और पायरीमेथामाइन विल इनिबिट द second last step of the synthesis of DHFA. Okay. This is a mechanism of action from medicinal chemistry point of view. So you can see here dihydropteroid diphosphate is there. जो हमने यहाँ पे लिखा है टेरिडिन. Okay. So pteridine is nothing but this is the dihydropteroid diphosphate component, it's a phosphate component, phosphate salt है वो, and this is the enzyme dihydropteroid synthetase, which we have written in the previous slide, pteridine, okay, synthetase. Okay, I'm sorry, it is this particular step. Okay, dihydropteroic acid and dihydrofolate synthetase. Okay, so it is going to replace the PABA. And okay, see the structure of PABA and this is the structure of sulfanilamide. This competitive antagonism, दोनों एक दूसरे का bioisosteres है, and it is going to form dihydroteroic acid. Dihydroteroic acid is further converted to dihydrofolic acid, and dihydrofolic acid is further going to convert to tetrahydrofolic acid, then thymidine, and then DNA. So this is a medicinal chemistry perspective mechanism of action of sulfonamides. So PABA को easily replace करता है अपना sulfanilamide. Okay, the bacterial resistance to sulfonamides. Now what happens, sometimes the sulfonamides are not that much effective, so what we say that resistance आ गया है हमारे sulfa drugs को या sulfonamides को. So what are the different mechanisms of resistance? म्हणजे एखादा sulfonamide तुम्ही घेतला तर तो त्याची ऍक्टिव्हिटी का नाही दाखवणार. These are the some of the reasons. Okay, सबसे first important चीज and that particular thing is common occurring nowadays is mutation. Okay, even for COVID-19, we are looking into the different mutants which are available for COVID-19. Even they say that Delta Plus is a variant, it's a mutational variant of the COVID-19. So, what is mutation? It is the altered bacterial enzymes which do not have affinity for sulfur drugs. Means what? What dihydropteroid synthetase upon which the sulfur drugs they will act, they will replace the PABA. ये इनिबिट करता है ये एंजाइम को, डायहाइड्रोटेरोइड सिंथेटेज को इनिबिट करता है सल्फोनामाइड. सो दिस डायहाइड्रोटेरोइड सिंथेटेज एंजाइम it will change its genetic makeup. Okay, it will get mutate, upon which the sulfonamide is not going to, cannot inhibit that particular mutated dihydropteroid synthetase. So that is one of the reason for acquiring the bacterial resistance by the sulfonamides. Second चीज क्या होती है कि when the sulfur drugs they come in contact with the dihydropteroid synthetase enzyme, what happens is that the PABA production in the bacteria, it starts to increase. Okay, this is to combat, this is to oppose the entry of sulfonamide. की सल्फोनामाइड्स आता येत आहे ना, मग आता आपण बॅक्टेरिया काय विचार करतं की पाबा प्रोडक्शन आपण वाढवू. So when the PABA concentration it will exceed the concentration of sulfonamide, then sulfonamide will not be able to competitively antagonize that particular enzyme. Okay, because it is competitive antagonism, and we all know that competitive antagonism is related to the concentration of the substrate, and there is the concentration of agonist and the concentration of antagonist. इथे agonist कोण आहे? PABA. आपला अँटागॉनिस्ट कोण आहे? सल्फोनामाइड. ओके, तर पाबा किंवा अगॉनिस्टचं कॉन्सन्ट्रेशन वाढलं तर अँटागॉनिझम इज नॉट पॉसिबल. ओके, next is bacterial cell, it will produce an antagonist of sulfur drug. See, every bacteria will have a self defense mechanism. So during that self defense mechanism, the antagonist of that sulfur drug is itself produced by the bacterial cell to neutralize it. Okay, this is about the biochemical perspective. Now the fourth reason is decreased permeability of bacterial cell to the sulfur drug. Sulfonamide, when it approaches to that bacterial cell, what will happen? The bacterial cell, it will see, it will decrease its permeability. त्याचं जे आवरण आहे किंवा बॅक्टेरियल सेल वॉल जे आहे ते सेल वॉलचं नेचर बदलेल स्वतः बॅक्टेरियल सेल. If the nature is changed, then permeability is decreased, then physically the sulfonamide or the sulfur drug cannot enter into the cell. Okay, that is another mechanism of resistance. The last one is the production of altered dihydrofolate reductase. आता पहिला आपण काय बघितलं? म्युटेशन ऑफ डायहायड्रोटेरोइड सिंथेटेस. लास्ट मध्ये आपण काय म्हणतोय की डायहायड्रोफोलेट रिडक्टेस ज्याच्यावर ट्रायमिथोप्रिम किंवा पायरिमिथामाइन ऍक्ट करणार आहे ते अल्टर होईल. त्याच्यामुळे काय होतं की सल्फोनामाइड जरी दिलं, सल्फोनामाइड ऍक्ट होत आहे पण तुम्हाला रिझल्ट मिळतोय का? नाही, तुम्हाला रिझल्ट तितका मिळत नाहीये. द इन्फेक्शन इज नॉट गेटिंग क्युअर्ड बिकॉज सम ऑफ द फोलिक ऍसिड इज स्टिल बीइंग सिंथेसाइज्ड इन द बॅक्टेरिया and the bacteria is now growing. Okay, it is not getting inhibited totally. That is why these are the some of the mechanisms of resistance. This is synthesis of sulfanilamide. Okay, basic synthesis of sulfanilamide. You can see it's acetanilide. Acetanilide is reacted with chlorosulfonic acid. The SO2Cl group is implanted at the para position of acetanilide. Okay, para position, why? Because this chlorosulfonic acid is electrophile and ortho and para isomers are produced because ortho para activator है ये जो group है NHCOCH3. तो out of the ortho and para, the para and is separated from the ortho, and we have to take the para acetamide of benzene sulfonyl chloride. Okay, with the liberation of H2SO4, and this is now ammonolysis, subjected to ammonolysis. So what is happening? Cl is getting lost, and this hydrogen of the ammonia is getting lost at HCl, and SO2Cl is getting converted to SO2NH2. So a sulfonamido group is created at the para position, and then finally it is subjected to acidic hydrolysis, H2O HCl, that is it is refluxed in the presence of dilute HCl in presence of water, and this group is the CH3CO group is hydrolyzed to form NH2. So it is resulting in the formation of sulfanilamide. Now sulfanilamide is a basic sulfur drug from which different derivatives like sulfadiazine, sulfamethoxazole, sulfadimidine, all these sulfonamides are synthesized. So the basic parent molecule is sulfanilamide, which is having N1 and N4. N1 is, we have discussed already, it is sulfonamido nitrogen, and N4 is the amino nitrogen at para position. Next is the synthesis of sulfacetamide. Sulfacetamide, you must have noticed that sulfacetamide is having a very wide application in the use of eye drops. So this sulfacetamide is synthesized from sulfanilamide. As I've already told you, it is a precursor. So sulfanilamideचं synthesis आपण आधीच्या स्लाइडमध्ये बघितलं आहे. तर सल्फासिटामाइड सिंथेसाइज तुम्हाला एक्झाममध्ये लिहायचं असेल तो यू हैव टू स्टार्ट फ्रॉम एसिटानिलाइड. ओके, एसिटानिलाइड से आपको तैयार करना है सल्फानिलामाइड और सल्फानिलामाइड से आपको ये सिंथेसिस लिखना है सल्फासिटामाइड का. ओके, सो सल्फानिलामाइड व्हेन इट इज ट्रीटेड विद एसिटिक एनहाइड्राइड यू कैन सी दैट इट इज एसिटाइलेटेड. ओके, एट बोथ पोजिशन दोनों भी नाइट्रोजन के जो प्रोटॉन्स है दोज आर एसिटाइलेटेड विद COCH3 and COCH3 which is subjected to zinc and in the presence of basic medium. So you can see here hydrolysis is taking place. So if you control the stoichiometry of the reaction, means if you are using 1 mole of zinc, okay, and NaOH 1 mole, then one of the group, that is the NH2 group, which is more basic one, it is getting hydrolyzed and the COCH3 is getting removed. Okay, if you are using 2 moles, then both the groups will be again you will get the NH2 and SO2 NH2, that is sulfanilamide, again you will get. But if you are using only 1 mole, then preferably the NHCOCH3 will be hydrolyzed to give the NH2 group and you will get the sulfacetamide compound. Then synthesis of sulfamethoxazole. Sulfamethoxazole is synthesized from this intermediate. This intermediate is called N5. Okay, at 5 position 1, 2, 3, 4 and 5. 5 position ला तुम्हाला ग्रुप आहे कुठला कार्बामिक ऍसिड. NHCOOH is called carbamic acid. So N5 carbamic acid. And what is this particular heterocycle? It is called isoxazole. When nitrogen and oxygen are neighboring to each other in a heterocycle, it is called isoxazole. आणि जेव्हा ऑक्सिजन आणि नायट्रोजन एका कार्बनचा डिफरन्सनी ते सेपरेटेड असतील तर आपण म्हणतो त्याला ऑक्सॅझोल. ओके, बट दिस इज नेबरिंग टू इच अदर, सो दे आर कॉल्ड आयसोक्सॅझोल. अँड विच आयसोक्सॅझोल? at 5 position there is methyl and at 3 position there is ill. Okay, ill means this carbamic acid group at 3 position. So I'm sorry, the numbering is like this. Oxygen will have the first number because it is having higher atomic number. So 1, 2 and this is 3 position, this is 4 and at 5 position there is methyl. At 3 position there is alkyl group. So ending काय म्हणतो आपण? ill. Okay, suffix त्याला ill म्हटलंय आणि कुठलं ill? Carbamic acid. Okay, so this particular compound is you can say it is subjected to decarboxylation reaction. High temperature वर याला pyrolysis करायचं, heat करायचं. It is going to lose the CO2 group and NH2 हा जो hydrogen है, this is getting transferred on the nitrogen to form convert NH2 to NH2 group. Okay, and this is a 3 amine which is prepared. This is treated with para-aminosulfonyl chloride group and this there is loss of HCl. Okay, this Cl is getting lost of SO2 Cl चा Cl चालला जाईल आणि NH2 isoxazole चा NH2 चा एक हायड्रोजन it is lost as HCl and you will get the sulfamethoxazole compound. Okay, just let me check the timing of the video. Okay, we will stop temporarily here.